Okay guys, so we're going to go ahead and just go through some examples on this section. If you need any explanation of some of the formulas, you'd find that in the introduction video before this. So the approval rating of a certain politician is changing at the rate of R of t. So this is the rate. We're doing the definite integral of the rate. So this would be net change from 0 to 3. So the rate of change of the approval, not the rate of change, the total change. So how much did it increase by, or how much did it decrease by? The change in the percent of the population who approves of the politician during the first 3 months. Well, that makes sense. The average rate of change, no. And the percent of the population. So once again, this represents the total change that happened. Not the average rate, not any rate of change, just the total change. A little bit different than rate of change. This seems pretty simple. So a water tank is filled at a rate of R of t liters per minute. So what does R prime from 1 to 7 mean? So this is saying the change in the rate of being filled between t equals 1 and t equals 7. The average rate of filling, no. The amount of water filled, no. The amount of water would be the integral of R, since R is the rate. And then the rate at which the tank was filled at t equals 7. I believe it's A, because notice this is talking about R prime. This is the derivative of the rate in this case. So that's saying the change in the rate of being filled. If it was, once again, just the integral of R, then it would be the amount of water that was filled. It would be the net change in the water. But we're going down basically to a second derivative here because R is already the rate. All right, looking at this one, the population of the town grows at a rate RT. At t equals 3, the town's population is 1,000. So we have this initial value of 1,000 plus the net change in the population because of the integral of the rate equals, so that would be the formula for the ending value, right? The ending value equals the initial value plus our net change, or our starting value plus the total change. So this is basically saying that, yeah, at t equals 8, at time equals 8, our ending time, the population was 1,500. And this last one, looks like we have the number of subscribers to a magazine is changing at a rate R of t. So here, R is the rate. We're going back to the derivative of the rate again. So the total change in the rate is 7. So the rate of change in the number of subscribers increased by 7 per month between t equals 8 and t equals 10. That seems pretty good, but let's just check the others. This number of subscribers increased. No, that would be if we did the integral of R. That'd be the total change in subscribers. The average rate of change, no. And then as of month 10, the magazine has 7. No. So here we go. The rate of change in the number of subscribers, it changed by 7. Because remember, this is the rate of the rate. So doing the integral of that would give us the rate, the total change in the rate. So that's kind of a twist, but we got 2 of those in there, and those are kind of the hardest ones to understand. But just basically go through those formulas, think it through. This section should more or less make sense though.